Welcome. In this video, we're going to use the ratio test to determine whether this series converges or diverges. So recall that the goal of the ratio test is to evaluate this limit, that is, the limit as n approaches infinity, of the next term, that's the nth plus 1 term divided by the nth term, and we want just the positive version of that. So if we have L less than 1, then the series converges absolutely. If L is greater than 1, the series diverges. And if L equals 1, the test is inconclusive. All right, now that we have that out of the way, let's identify our nth term and our nth plus 1 term. Well, the nth term is n to the n power over n factorial. And the nth plus 1 term is equal to n plus 1 to the n plus 1 power divided by n plus 1 factorial. And as a quick aside, if you are unfamiliar with factorial notation, this is just our number, so in this case n, multiplied by every integer less than it all the way through 1. So n minus 1 times n minus 2, and so on all the way to 3, 2, 1, depending on the size of this number. So for example, 4 factorial is 4 times 3 times 2 times 1 is 24. 5 factorial is 5 times 4 times 3 times 2 times 1 is 120. So there are a couple examples. All right, let's continue with this. So the limit as n approaches infinity of the next term over the previous term is equal to the limit as n approaches infinity of n plus 1 to the n plus 1 power divided by n plus 1 factorial. And then in our denominator, we have n to the n divided by n factorial. Okay, this is all equal to L. So this is the limit as n approaches infinity of n plus 1 to the n plus 1 power divided by n to the nth power times n factorial over n plus 1 factorial. Okay, so we have some cleaning up to do. So let's take a look at this portion first. So n factorial is equal to n times n minus 1, and so on. N plus 1 factorial, well, that's equal to n plus 1 times n minus 1, and so on. That's because we're subtracting 1 each time, and we multiply the next integer, so n plus 1 minus 1 is equal to n, and that's how we get this n here. Well, if you notice, this entire part here, that's just n factorial, so n plus 1 factorial is equal to n plus 1 n factorial. All right, so I'm going to rewrite this. And you'll quickly note I made some things smaller just so we have more space for our limit and not so much for these asides and these things to remember, etc. So this is the limit as n approaches infinity of n plus 1 to the nth power over n to the nth power times n plus 1 times n factorial over n plus 1 times n factorial. Few things are going to cancel out, so to speak. These n plus 1s match on the numerator and denominator, as do the n plus 1 factorials. All right, this leaves L is equal to the limit as n approaches infinity of n plus 1 over n to the nth power. This is a really important limit from the first semester of calculus, as this is the limit definition of the number e. And that is larger than 1. So since it's larger than 1, we are here in this case. This series diverges. Now, before I end this video, I just want to give some advice here when it comes to series. If you see a factorial, it's probably a good idea to try the ratio test. Hopefully you found this video more fun than a barrel of monkeys.